So we'll continue with questions. The speed limit along a certain road is 80 kilometers per hour. To stop at a junction, the driver applied excessive force on the brakes. So here is a vehicle that is moving. It's going forward. Now, to be able to stop this vehicle, a driver has to apply excessive brakes, and brakes act in the opposite direction to the direction of motion. In other words, they provide a friction force. Okay. And then before, just when the brakes are applied, this vehicle is moving with a certain velocity, which we don't know. But when these brakes are applied, the vehicle, instead of it just stopping, it skids before getting to stop. And it skids for about 55 meters, and then the final velocity is zero. That means it now stops. The final velocity is now zero. The coefficient of kinetic friction between the tires and the road has been given. That is, coefficient of static friction has been given. Now I want to find what was the initial velocity here so that we compare it to the speed limit. We see if the driver exceeded the speed. And the first thing that you have to do with such a question is you need to look at the net forces acting on this object. You can see this object is only moving in the x direction. It's not moving up or down. So that's why I've said net force in the x. And do we have, when you're finding the net force, it's always applied force minus friction force. Do we have any applied force? It didn't apply any force in the direction of motion. So applied force is zero. And then minus any friction force, the brakes provided a friction force. So the net force is given by mass multiplied by the acceleration, and that will be equal to negative friction, and friction is given by coefficient of friction or coefficient of kinetic friction multiplied by the normal force. Normal force, this vehicle is on a straight surface, so normal force is equal to mass multiplied by the gravity, which is weight force. The mass cancels with the mass, so the acceleration therefore is equal to negative mu k times g. Acceleration is going to be negative 0.75, g is 9.8. So the acceleration is going to give us negative 7.35 meters per second squared. The reason as to why it's negative is because the vehicle is going to a stop. That means it is now going to be a deceleration. To find the initial speed, since we know now the acceleration and the final speed and also the distance, we can say final velocity squared is given by initial velocity squared plus 2as. Final is 0. Initial is what we want, plus 2. The acceleration, negative 7.35. And then s, which is the distance covered here, 55 meters. If we multiply these terms, we are going to get 2 times negative 7.35 multiplied by 55. It is going to give us 323.4. Take it the other side. So u squared is going to be, if this term goes the other side, u squared is going to remain alone here, and then this is going to become positive 323.4. Square root both sides, u is going to give you 17.97. This is in meters per seconds. Now to be able to compare, I can either convert this one to meters per second to compare with this, or I convert this one to kilometers per hour, I compare with this one. It doesn't matter, it will all be the same. So let's convert this. The initial velocity that we had is 17.97 meters per second. So we'll multiply. We have got a meter on top, we'll bring a meter down, and then a kilometer on top. In 1 kilometer, we've got 1,000 meters. And then we have got a second down, we put a second on top, and then a hour down. In 1 hour, we've got 3,600 seconds. So this second here cancels. The meter cancels. This is going to give us 64.8 kilometers per hour. So now we can conclude. So such a question, the question is saying determine the drive if the driver exceeded the speed limit. You will not just say that the driver didn't exceed or the driver exceeded. You'll find this 10 marks or 12 marks. So you now make a statement. Since the initial speed was less than the speed limit, therefore the speed limit wasn't exceeded. Do we have questions on this? Are we good now? All right. The next question here. A 1000 kg car accelerates from rest to 10 meters per second in 7 seconds along a straight road. How large a force is needed to achieve this? So here you have a car and it just accelerates from rest and it is moving at a velocity of 10 meters per second. That moves for a time 7 seconds. Now, how large a force is needed to do this? So the first thing we need to be able to determine, if we are talking about, we want to find the force that is needed to accelerate this car, we need to be able to determine the what? The acceleration at which it moved. Okay, so we know that final velocity is given by initial velocity plus acceleration multiplied by the time. Final velocity, it accelerates from rest. That means this same 10 is the final. From rest, meaning that the initial speed was 0, and then plus acceleration, the time is 7. So we'll divide both sides by a 7, because 0 plus a7 is just the same as 7 or 7a. So therefore, this and this will cancel, remain with a. So 7 into 10, that will be about 1.42857 meters per second squared. This is the acceleration. Now we want the force, how large the force is needed to achieve this speed. So from Newton's second law, force is given by mass multiplied by the acceleration. This is a 1000 kg car, and then the acceleration is 1.42857. So when you're multiplying a number by a number that has got zeros, just count the zeros like multiples of 10. We have got 3 zeros, so the decimal point to move 1, 2, 3. So therefore that would be 1428.57. Now it is in Newton. So this is the force that is required to achieve that. Okay, the next one here. An 8 kg wagon is pulled by a force of 20 newtons at an angle of 40 degrees above the horizontal. So here you've got the wagon. The horizontal is here. This is the horizontal. And you are pulling this wagon by a force of 20 newtons at an angle of 40 degrees above the horizontal. So you have got 40 degrees above, on top of the horizontal. Now we want to determine the wagon's acceleration, the reaction force the ground exerts on the wagon. So starting first with the wagon's acceleration. How are we able to determine the acceleration? So if you look at this force, it is not applied linear, it's not applied straight like that. So this force is going to have two components. It's going to have the x component going in this direction, so I'm going to say fx, and it's also going to have a y component going up, which we are going to call fy. So we need to find these two components. Starting with fx, we did vectors, we did projectile motion. X component is given by the force cos the angle. Y component is given by the force sin the angle. So the x component, the force, is 20 cos 40. And then here it will be 20 sin 40. So 20 cos 40, this is going to give us 15.32. 20 sin 40 will give us 12.856. Now you are pulling this thing at this angle like this. If you want to determine, you can determine the weight of this object. How do you find the weight? Well, the weight of the object is given by mass multiplied by the gravity. The mass here is 8. Gravity, let me use gravity just 10. Okay, rounded off. Of course we use 9.8. I just want you to see something. This will give you 80. So meaning that the downward force is 80 kg. So this component of the force, which is going in the y direction, is not big enough to lift this object. In other words, this object will not be able to move up because the y component is not greater than the weight. Because of that, this object, this force we've applied, the component is not enough to pull the object up, meaning the object will just be able to move forward, it will not be able to move up. Okay, so therefore the acceleration of this wagon, we know that force is given by mass multiplied by the acceleration. So in this case, the force, this object is only moving in the x, so this force is going to be a component in the x. So the component in the x, that is 15.32, and that is going to be equal to mass, which is 8 multiplied by the acceleration. So divide both sides by 8, that is going to give us about 1.95 meters per second squared. This is going to be the acceleration of the object. Never use the force they've given you just here. No, you need to get a component that goes in the direction of the applied force.